Hello friends, today we are going to see how to implement the multi-layer perceptron in machine learning, right? So already we have saw single layer and today we are going to see about multi-layer perceptron. What is the difference between it? Single layer perceptron, you will have only the input layer and the output layer. But here we are going to have many, right? So how to add the weight to it and how we are going to have the BIOS to add with that and then activation function for each layer. Likewise, we are going to see one after another and if any error occurs, how the back propagation to be done and change the weight and how we can reduce the loss function. Likewise, we are going to see in this particular code. Okay, so for that first, I am going to for import torch. It's a library. Okay, so we are going to use TensorFlow for MLP performance. Okay, so then only we can do this back propagation and all easily, right? And also, as you know, this is a complex structure, but if you want to make it as like a simple model, we have to go for this TensorFlow for MLP, or otherwise it is very tough to implement. So first we are going to import the library torch in which we are going to give torch.nn, that is neural network, as alias name as nn. And then for optimization, that is torch.optim as optim. Okay, so that is the alias name. And then from sklan import data sets. Okay, what are the data sets we are going to use it? Here we are going to use iris data set. And then sklan.model selection import train test split. So whenever we are having the data set, we have to do splitting the training and testing data. And here we are going to how we are going to store it as like a dimensions and how we are going to do it after we are making the train test split. That means what? You will have X train and X test, and then you will have Y train and Y test, right? Likewise, we will have a separate, okay, that is split, right? And then sklan dot pre-processing. Okay, so the import standard scalar. That means what? The according to one particular range, we have to pre-process it, right? So that's why we are using this standard scalar. And then we are going to import numpy, that is numerical Python as NP. Okay, likewise we are giving the alias name. And then from sklan dot metrics, we are going to import that is performance metrics like confusion matrix, accuracy score, precision, recall, effort score, and so on. Right. So these are the things we are going to first import, and then we are going to start loading the data set, iris data set. That is iris equal to datasets dot load iris. We have iris dataset is loaded, and then we are going to give the features and the labels. X is a feature and Y is like target, right? So how we are going to give which is equal to iris dot data, comma iris dot target. So this is the input layer and this is like an output layer, right? X comma Y, that is iris dot data, and then this is the target. So you will have a multiple independent variable, but only one dependent variable, right? That is called the target. And then standardize the features. Okay, as I told you, standard scalar, which is help us to scale the value. Or otherwise, the range of one numerical value will be lower, another value will be so higher. So it is very tough for us to analytic it. So what we can do is we can go for standard scalar to scale the value, okay, which is present inside. And then we are going to give fit transform. That means what? Whatever feature extraction or whatever cleaning process that is done, that have to be reflect to the original uh, variable. Okay, so that's why we are using this fit transform. Fit transform is whatever modification, whatever scaling we did with the thing, okay, with the subset of the data set, that have to be again transformed into the original data set. Then only whatever we pre-process we did will be going to useful. And then we are going to split the data set into 80% training and 20% testing. See here, X train, X test, Y train, Y test, and then train test split, in which I have to give X comma Y, and then test size is 0.25 and then random state. Okay, so this is the function which is helpful for splitting the training and test data. So converting to PyTorch tensors. Okay, till now we did as usual how we did. Now we are going to convert to the PyTorch tensor. It means X train X test is equal to torch dot tensor, in which I am going to pass the X train and then X test, okay, in the X train X test, and then Y train and Y test, okay, in which I have to give the data type which is starts dot long. Got it? So dot long, or we are going to use this PyTorch tenses. Okay, PyTorch tenses, we are just converting to it. Okay, and then we are going to find the size of the X train after splitting it. That's why we are just giving it. Okay, and then we can see the row size, column size. Okay, all that thing we can see when you are giving torch dot size. And then coming to the next, that is class MLP. Now we are going to concentrate on the multi-layer perceptron, in which I have to pass the NN dot module, that is neural network dot module, in which I am giving the initially I am giving self dot FC1. Okay, that means what? Initial input layer. Okay, so we have 42 layer in which 32 neurons is there. So as you know about perceptron, you will have like a neurons, right? So here also initially we are saying that input layer, okay, in which four layers in which 32 neurons. So that means eight neurons in each layer, right? And then hidden layer, that is now this 32 neurons will become 16. Got it? And then again the hidden layer 16 becomes 8. And finally, the output layer, we are saying that because there is no activation there. So that's why we are getting 8, which will become like a 3 classes. That is the final output layer. Okay. And then we are going for the ReLU activation. Okay. So that is the thing we are going to do it. Okay. Activation. So how to give this function? Here just we are giving it as like a function name, but how we are going to use it. Okay, so first let us see that the forward. Okay, the first hidden layer. Okay, so everything we have to give it as like ReLU. Okay, so that is ReLU activation, right? So of self dot FC1 of X, that is first hidden layer. Okay, and then secondly FC2 second hidden layer, FC3 third hidden layer. Okay. So likewise, you will get for everything, you will have the optimization, that is ReLU. Okay. So that have to be done. But for the see for the output layer, there is no activation. Okay. But all the three we have the activation that is named ReLU, right? But here you can see in the output layer there is no activation. Okay. So that is the main difference. And then cross entropy loss, that which includes the softmax. Okay, so that is how the output layer will be, and then we are going to initialize the model. In which initializing the model, we are going to give CUDA. Okay, if torch CUDA is available, else CPU. That means GPU. That is CUDA. That is graphical processing unit and CPU. It will check whichever thing is free, right? Okay, so according to that, it will switch over. Okay. So then after initializing the model, now we are going to, so model equal to MLP function to device. So either to the CPU or to the GPU. Okay, it can be okay. So sent to the device. Okay, and then we are going to import the matplot. So now we are going to go for the ML, and then we are going to visualize it. Okay, first we are giving the last values as like declaration as an empty array, because we are going to find out if any loss values which is there. So define the loss function and optimizer. That is, we are giving the Ross entropy loss. So that is the multi-class. Okay. So this is for the multi-class, and for optimizer we are using Adam. Okay. So already we have seen in the theory parts. Okay. So model one, model dot parameters in which I is equal to 0.01. Okay. This is the optimizer method we are going to use. Okay. And then move data to GPU if available. So we are splitted X train, Y train, in which X train two device, okay, and then Y train two device. We are giving it out whichever thing is available. Similarly, X test and Y test also we are doing the exactly the same. X test two device and Y test two device. Okay, so likewise I can transfer the thing. Okay, and then how we are going to make a training loop in which epoch is nothing but it is an iteration. So we are giving for 100 iterations. For each iteration, we are giving in the range as I equal to 0, right? And then model train, set model to training mode, okay, in which I am going to give the optimizer that is 0 grad. Okay, so that is recently gradients. And then outputs equal to we are giving the model of X train. That means forward pass. Okay, so passes mainly training the data to the model. Okay, and then we are going to give loss. Okay, so for that we have to compute it, right? So which is equal to criterion of outputs, comma Y train. Okay, so we are finding out the criterion of it. Okay, and then loss dot backward, that is compute gradients via back propagation. As I told you, if the weight is abnormal, we have to change the weight. We have to go for back propagation. Okay, so that is how we are going for it. And finally, optimizer. Okay, updates the model's parameter using the optimizer. Okay, so these are the things we have to concentrate, okay, for the initial step, and then we are going for store the loss for the visualization. So that is loss values upon loss items. Okay, so already it is there. If epoch plus 1, that is percentage 10, which is equal to 0. Okay, so print epoch plus 1, and then num epoch and loss dot item of 4f. Okay, so that is the format, right? Giving, right? So after this, we are going for loss for visualization. Okay, so that only we are actually doing, and then how we can set the model to mode. Okay, so evaluation mode we are going to set the model. Okay, so model dot eval, that's the function name, with the torch dot no grad. Okay, so here there is no loss function. If it is there, okay, then output which is equal to model of x test, that is forward pass, right? And then we have the predicted label, right? That is a predicted, which is equal to toss dot max of outputs comma 1. Okay, so this is the predicted label, right? And then we have to convert these tensor to numpy arrays. Okay, how to do that? We are going to just give y test of np, which is equal to y test dot cpu dot numpy. Okay, so we are just transforming to the device, that is cpu. Okay, predicted np, which is equal to predicted cpu dot numpy. Okay, so we have the original target and also predicted value. Okay, so with that we have to compare it, right? You have to find the difference to find the loss, right? And then we are going to compute the evaluation matrix. Okay, metrics. Evaluation matrix, either it may be confusion matrix, accuracy score, precision score, recall score, and then finally we can say F1 score. Got it? So all these things you can evaluate the metrics using the formula. So for that, we are just printing all the performance metric according to the format, and it will be displayed. Okay. So this is how it is a thing. And finally, we are going to plot the graph. Okay, so for the text label, we are giving the epoch. So as I told you, 100 epoch, right? So up to the 100, we can see the epoch, right? So for that, how the graph is drawn. Y label is the loss, and the title is staining loss curve. And then we are giving legend. That means this have to be printed. And then it is in a grid format and finally to show. Okay, so we got the result for the 100 iterations, right? I hope you understood the code of MLP. Okay, so please study along with the theory about MLP and then learn here the code. All these things are predefined function. Directly you are using it. Okay, so be careful in understanding the concepts. Okay, so all the best. Okay, so we will see with the next in the next video. Thank you.